The lesson topic for this video is applications using Trig. So, first of all, another word for applications using Trig means word problems. And before we get into a couple of examples of word problems using trig ratios, I want to use go over a couple of definitions. Angle of elevation and angle of depression. Typically, angle of elevation is not an issue for most students because it makes a lot of sense as we look at the diagram. However, angle of depression is often done incorrectly. I'm going to show you why in our diagrams. So first of all, angle of elevation. Well, the angle of elevation says when looking up at an object, it's the angle your line of sight makes with a horizontal line. Now that's key right there, horizontal. So let's say we're standing right here, okay, and we're looking up at an object right here. So here's you, and this is the object up here that you're looking at, okay? So when looking up at an object, it's the angle that your line of sight, well obviously this right here would be your line of sight. That's where your sight is going. It's the angle that your line of sight makes with a horizontal line. This is a horizontal line. Vertical is going this direction, right? All right, so this is the angle right here of elevation. Okay, so that one is pretty straightforward. But the angle of depression is the one that people make mistakes with. This one says, when looking down at an object, it's the angle your line of sight makes with a horizontal line. Again, with a horizontal line. So now this time, here's you up here, okay? And the object you're looking down at the object, that's over here. So here's your line of sight looking down at the object, and it's the angle that your line of sight makes with a horizontal line. What a lot of people want to say is that this right here is our angle of depression. But that is the line of sight, the angle created by the line of sight in a vertical line. So this is not the angle of depression. What we have to do is we have to create the horizontal line ourselves. So there's the horizontal line. So we're talking about the angle that's created by your line of sight and a horizontal line. So we need to draw that in ourselves. This is the angle of depression. So again, that's the one that people have more of a difficulty with. Let's take a look at some examples. For our first example, it says you are at the top of a roller coaster 100 feet above the ground. The angle of depression is 44 degrees. How far do you ride down the hill? Well, first, let's put a little picture of ourselves up here in the roller coaster car because that's fun. So there you are at the top of the roller coaster, arms up. Wah! Okay, so you're at the top of the roller coaster 100 feet above the ground. So you are currently 100 feet above the ground, which means that this is 100 feet. The angle of depression is 44 degrees, and that means as you're looking down at the bottom of the hill, your angle of depression is 44 degrees. Okay, so again, angle of depression means the angle created by your line of sight. This is your eyes looking down at the bottom of the hill. That's created with that line of sight and a horizontal line. So we need to draw in a horizontal line right here. So the line of sight and the horizontal line creates this angle right here. That is our angle of depression, and it is 44 degrees. The question then is, how far do you ride down the hill? All right, so if we're trying to find out how far we ride down the hill, let's put an X there. We're trying to find the side length that goes from where you are to the bottom of the hill, right? So that's X. All right. Based on using sine, cosine, or tangent, and we can think about the three trig ratios in the idea of SOHCAHTOA, we need to figure out the length of the side of the triangle that we need, which is X. Now, when we're using a right triangle, we need an angle in the right triangle in order to use our trig. We do know that this is a right angle down here, and that's good because we need a right triangle to do our trig. Okay, what other angle could we currently use? Well, most people will take a look at this angle right here and determine what that angle measure is. Now you have to think back to geometry, and you have to think about how this angle right here that's 44 degrees and this angle right here that we are looking to find have a sum of what? Well, the answer is they have a sum of 90 degrees because they create a right angle together. This is a horizontal line and this is a vertical line. So this angle right here is 90 degrees. So if we take the 44 degrees away from 90, we get 46 degrees remaining for this angle right there. Now, we can ignore anything that's outside the triangle over here. We don't need to worry about that because now we can just look at this right triangle. We have a 46-degree angle, we have a 100-degree side, and with those two pieces of information, we have enough to find our missing side. So I'm going to label with, I don't know, some darker color that shows up here, purple, my sides. So first of all, across from the right angle, this over here is the hypotenuse. And if we're using the 46-degree angle right here, opposite of that would be this side down here. So that's the opposite side. And that leaves this as being the adjacent side. So now we think to ourselves, which trig ratio do we need to use if I'm trying to find x, which is the hypotenuse, and I know this 100 right here, which is the adjacent? Well, adjacent and hypotenuse are together in the cosine ratio, so that's what we're going to use. So the cosine of our 46-degree angle is equal to the ratio of the adjacent side over the hypotenuse. The adjacent side is 100 if you look in the diagram, and the hypotenuse is x. Okay, so now we can simply use a proportion. We can turn this into a fraction. Now we can use a cross multiplication to solve. So 100 times 1 is 100, and the cosine of 46 times x is the cosine of 46 times x. To solve for x, because here it is right here, to solve for x we need to divide by the cosine of 46 because they're being multiplied. So I'm going to divide this side by the cosine of 46 to cancel these out, and I would need to then divide by the cosine of 46 over here. So x equals, we get 143.956 for x. So how far do we ride down the hill? Well, about, and we could round to 3 decimal places as well, but about 144 feet. Okay, for this second example, it says a chairlift on a ski slope covers a horizontal distance of 4,640 feet. The vertical height covered by the chairlift is 3,500 feet. What is the angle of elevation of the chairlift? All right, so first again, I'm going to draw a little diagram. So let's say this is the ground at the ski resort, and here is, I don't know, a mountain. And the ski lift starts in this little spot here, and it goes up the mountain to the top. And think about a ski lift, if you know anything about them. They have these little chairs. People are sitting on them. Okay? So, it says, the chairlift on the ski slope covers a horizontal distance of 4,640 feet. So, if I kind of drew a vertical line here, this would be my right angle with the ground. It's 4,640 horizontal feet. The vertical height that's covered by this chairlift is 3,500 feet. What is the angle of elevation of the chairlift? So that means we are looking for this angle right here. The angle of elevation of the chairlift is the angle that is created if you were to look standing here at the top of the mountain up here. So we want to find this angle. What do we need to use in order to find an angle? Well, we need to use inverse trig, right? because if you're trying to find an angle, you have to use inverse. So let's first label our sides. This is our hypotenuse. It's across from the right angle. Opposite of the angle right here that we're talking about is the opposite side, and remaining is our adjacent side. If the two sides that we know are the opposite and the adjacent, we are going to use the tangent ratio, because TOA tells us that the opposite and the adjacent are together in the tangent ratio. So the tangent ratio of that angle, let's just call it angle A, okay, is equal to the opposite side, which is 3,500, over the adjacent side, which is 4,640. Now, we can't take the tangent of a letter or a variable. We need to use inverse tangent in this case. So tangent inverse, and we're going to swap around the 3,500 over 4,640 with the A, or the measure of angle A. Now we're going to use inverse trig on our calculator to solve. And we get 37.076, so that angle is about 37 degrees.